Good morning, children. Let us start chapter number 2. Is matter around us pure? Now coming to classification of matter. As we know matter is anything which has its mass and it occupies the space. So according to the basis of physical state, matter is classified into three main types. They are solid, liquid and gaseous state. And on the basis of chemical composition of matter, it is also classified into two main types. They are pure substances and mixtures. Now, pure substances are again of two types. They are element and compounds. And mixture is also of two types. They can be homogeneous mixture and also they can be heterogeneous mixture. Let us see the difference of pure substances and mixtures. Now, pure substances, a substance which consists of single type of substance. It can be element or in compound form. For example, examples of element, iron, copper, hydrogen, oxygen. Example of compound, water, sugar, common salt, etc. Now coming to mixture, it is a substance which consists of two or more pure substances. Examples, seawater, mineral, soil, air, sand and salts, sugar in water, salt in water, etc. Now coming to difference between pure substances and mixture. Pure substances consist of single type of substance. Mixture consists of two or more type of pure substances. Second difference, pure substance cannot be separated by any physical method, but mixture can be separated into its component by the physical methods. Third difference is pure substances has its own definite properties, but mixture shows the property of its components. Coming to the types of mixtures, mixtures are of two types. One is homogeneous and other is heterogeneous mixture. So one by one we will see homogeneous mixture. It has uniform composition. The particle of mixture is not visible by the naked eyes. The particle cannot be separated by filtration method. The mixture is very stable. Particles do not settle down. The path of a beam of light is not visible in the mixture. Example, mixture of sugar in water, mixture of salt in water, mixture of copper sulfate in water, etc. Now coming to heterogeneous mixture, it has non-uniform composition. Particles are visible by the naked eyes. Particles can be also separated by filtration technique. The mixture is unstable. Particle settles down when it is allowed to rest, and the path of beam of light is visible in the mixture. Example is mixture of salt and sand, mixture of sulfur and iron fillings, mixture of oil and water, etc. Colloidal solution. A colloidal solution is a heterogeneous mixture of two or more substances. Examples are mixture of starch in water, mixture of egg albumin in water, milk, air containing dust and smoke, etc. Now coming to the properties of colloidal solution. First properties, colloidal solution is a heterogeneous mixture. Particle cannot be seen by the naked eyes. The solute particle cannot be separated by simple technique of filtration. The solute particle do not settle down when the solution is allowed to rest, or you can say solution is stable. The particles scatter a beam of light passing through it, and the path of light is visible in the solution. This is very important point to note it down. In the category of heterogeneous mixture, one another along with the colloidal solution, one is suspension. Suspension is also an example of heterogeneous mixture of two or more substances. Example is solution of sand in water, solution of chalk powder in water, etc. Now coming to suspension properties. Suspension is a heterogeneous mixture. Particle can be seen by the naked eyes. The solute particle can be separated by filtration technique. The solute particles settle down and the solution is unstable. The particles scatter a beam of light passing through it, and the path of light is visible in the solution also, like colloidal solution. This is the property of suspension through pictorial diagram. Now, solute particle can be separated by filtration technique. Solute particles settle down and solution is unstable, you can see. And solute particles scatter light and path of light is visible in the suspension. Tyndall effect. When a beam of light is passed through a colloidal solution, the colloid particle scatter the beam of light and the path of light become visible in the solution. This effect is called Tyndall effect. We have already seen some of the Tyndall effect. Tyndall effect can be seen when light enters a room through a very small hole due to scattering of light by the dust and smoke particle. Tyndall effect can also be seen in dense forest due to scattering of light by water droplet in the mist. Saturated solution. Saturated solution is a solution which cannot dissolve any more of a solute at a given temperature. Solubility we can define. A substance is the amount of solute present in a saturated solution of the substances. That is known as solubility of that particular solution. Unsaturated solution is a solution which can dissolve some more of the solute at a given temperature. Now, let us see the preparation of saturated solution, or you can say how we can make or prepare the saturated solution. Take 50 ml of water in 2 beakers, add salt in 1 beaker and continuous stirring till no more salt dissolve in it. Similarly, add sugar in the other beaker with continuous stirring till no more sugar can dissolve in it. We get saturated solution of salt and sugar. If the mixtures are heated, it dissolves more of the solute. So we can say solubility of different substances are different and solubility of substances varies with temperature. Concentration of a solution is a amount of solute present in given amount of solvent or solution. So how we can calculate mathematically the concentration of a solution? In the terms of solvent, we can calculate concentration of solution is equal to amount of solute divided by amount of solvent. Or in terms of solution, we can define it as amount of solute divided by amount of solution. The concentration of a solution can be expressed as mass by mass percentage also or mass by volume percentage also. So mass by mass percentage means mass of solute divided by mass of solution into 100. It is percentage, that's why we have to multiply it with 100. Mass by volume percentage of solution we can define mass of solute divided by volume of solution into 100. Now how we can separate the components of a mixture? There are certain techniques. So the component of heterogeneous mixture can be separated by simple methods also like hand picking, sieving, filtration, etc. And sometimes special techniques are used to separate the components of mixture like evaporation, centrifugation, decantation using separating funnels, sublimation, centrifugation, chromatography, distillation and fractional distillation. First technique is evaporation. In this method, it is used for separating a volatile component solvent from a non-volatile component solute by heating the mixture. Just see volatile solvent and non-volatile component. Volatile means which can, when we raise the temperature, it forms the vapors. Example, ink is a mixture of dye and water. If some ink is heated in a dish, the water evaporates. Water is a solvent, but it is volatile. It evaporates on heating and the dye is left in the dish. Similarly, we can separate a mixture of salt and water, sugar and water by evaporation. Centrifugation. It is the method of separating denser particles and lighter particles from a mixture by using a centrifuging machine or is called centrifugation technique. Example is very simple. If we take some milk in a centrifuging machine and spin it rapidly, the cream separates from the milk because of the cream is less dense than the milk. This is very common example you might have seen in the house for making ghee out of milk. Third technique is the decantation using separating funnel. This method is used for separating a mixture of immiscible liquid. What is immiscible liquids? Which are not dissolving or dissolving with each other. Liquids separated into different layers depending on their densities. Example we can take a mixture of kerosene oil and water in a separating funnel. It forms separate layer of oil and water. The water can be separated by opening the stopcock and the water flow out of the stopcock when it is closed. Another method is sublimation method. What is sublimation? The conversion of solid substances directly into gases is known as sublimation process. Example, camphor you have seen, or phenolphthalein, naphthalene balls which we use in our house. So this method is used to separate a mixture of sublimable component from non-sublimable component by heating the mixture. If a mixture of ammonium chloride and common salt is heated, ammonium chloride directly sublimates, means convert into vapor, and can be cooled and solidified and collected, and salt is left behind. Now another technique is chromatography. Chroma means color, graphy means measurement. This method is used for separating colored component from a liquid by using a filter paper or special type of blotting paper. Example we can see, put a drop of ink near one end of the strip of filter paper and dip the end of the paper in test tube containing water. Ink is a mixture of two or more colored components. The component which is more soluble in water rises faster and get separated. Another technique is distillation. This method is used for separating a mixture of miscible liquids. Miscible means which are soluble with each other or dissolve in each other, by boiling the mixture and cooling and condensing the vapor. Simple distillation techniques. It is used for separating mixture of two miscible liquids having sufficient difference in their boiling point. Example, if a mixture of acetone and water is heated in a distillation apparatus, the acetone has lower boiling point, means it boils faster than water. And water first and boils and cools and condenses and is separated from the water. Another technique is a fractional distillation. It is used for separating a mixture of two or more miscible liquids whose difference in boiling point is very less than 25 Kelvin. Now, the apparatus used for fractional distillation is similar to that used for simple distillation, except that a fractionating column is fitted between the distillation flask and the condenser. The fractionating column has glass beads which increase the surface of the vapor to cool and condense. Fractional distillation is also used for separating the component of petroleum and separating the different gases from the air. Now, separation of components of air by fractional distillation technique. As we know, air is a mixture of different gases. So, component of air or gases can be separated by fractional distillation. What are the techniques or the steps to be followed? Air is compressed by increasing the pressure. We pressurize the air and cooled or decrease the temperature of the air to get into its liquid form, or we are doing the liquefaction of the air. We got liquid air. Now this liquid air is then allowed to warm up slowly in a fractional distillation column. Then different components separate at different heights depending on their different boiling points. So we will get different layers of gases. or so the gases can be separated at different heights. Now the boiling point in degree centigrade of oxygen is 183 degree, argon 186 degree centigrade, and nitrogen 196 degree centigrade. Now purification of solids by crystallization process. Crystallization is a process by obtaining a pure solid in the form of crystals from its solution. So example we can see, by crystallization we can obtain pure copper sulfate from its solution. What we have to do is dissolve 5 gram of copper sulfate in minimum amount of water. Filter the solution to remove the impurities. Now evaporate the solution in a china dish to get a saturated solution. Cover the solution with filter paper and allow it to cool. Pure copper sulfate crystals are formed. So after mixtures, let us talk about the pure substances. Pure substances are basically of two types. They can be element, they can be in the compound form. Element is a basic form of matter which cannot be broken down into simpler substances by chemical reactions. Elements are of three types. They are metal, they can be non-metal, and metalloids. So coming to properties of first element, that is metal. Metals. They have lustrous property or shining property. They are malleable. They can be hammered into sheet, and they are ductile. They can be stretched into wire. They are good conductors of heat and electricity. They are sonorous or produces the melodious sound on heating. Example is iron, aluminium, zinc, mercury, copper, silver, gold, etc. Now coming to properties of non-metals. They are non-lustrous. They are dull in color. They are non-malleable and ductile, non-ductile. They are poor conductors of heat and electricity, and they are not sonorous. Example, hydrogen, oxygen, nitrogen, iodine, carbon, sulfur, phosphorus, etc. Properties of metalloids. Metalloids are elements which show some properties of metals and some properties of non-metals. Examples are boron, silicon, germanium, etc. Compounds. Another form is compound. Compound is a substance composed of two or more elements chemically combined together in a fixed ratio. Fixed ratio means you cannot change the formula of the compound. Example, water. We can see in water H2O, two molecule of hydrogen combined with one molecule of oxygen. Carbon dioxide, CO2, sugar, C6H12O6, salt, NaCl, iron sulfide, FeS, etc. Difference between mixture and compounds. Now, mixture. Mixture is composed of two or more elements or compounds mixed together, and compounds also consist of two or more elements chemically combined together. The composition of component is in any ratio. In mixture, composition can be in any ratio, but in compound, it is always fixed. Composition of the components are always fixed. In mixture, it shows the property of the components, but in compound, it shows different property other than the component. You can see water is liquid form, but hydrogen and oxygen from which it is made is in the gaseous form. The component can be separated by physical methods, we have already seen, and components in the compound cannot be separated by simple chemical methods.